everyone. Today we're going to start off chapter 1 with graphing categorical data. Throughout this chapter, we are going to compare athletes' performances in two different contexts. So a lot of times it's going to be the regular season versus the playoffs. We could also compare the first half of the regular season with the second half. But regardless, we're going to use graphs to compare athletes' performances in two different contexts. So, like I said, today we're graphing categorical data. First, we need to determine what's the difference between categorical versus numerical data. So, the definition of categorical variable is when outcomes fall into categories. Okay, seems easy enough, but sometimes it can get a little tricky. So for example, a categorical variable, an example would be eye color. Your categories are blue, brown, green. Another example could be political party. Republican, Democrat, the outcomes fall into categories. Outcome of a football game. For example, win, loss, or tie. You could also use math class, statistics, pre-calc, geometry. Outcomes fall into categories. Now, numerical variables are when the outcomes take on numerical values that represent different quantities of a variable, and I'll explain that. Outcomes take on numerical values that represent different quantities of a variable. Okay, so for numerical variables, they need to have quantitative meaning. So for example, height, height in inches. The higher the number you give me, the taller a person is. Test score. The higher the number, the better you did on the test. GPA. Distance traveled by a home run. Okay, they have quantitative meaning. The higher the number, the farther traveled, the better your GPA, etc. So, for example, one that might be tricky is jersey number. Okay, jersey number in sports. If your jersey number is 14 and your teammate's jersey number is 9, does that have quantitative meaning? Does that mean you play more minutes in the game because you have a higher jersey number? No. Okay, jersey number is just, it categorizes you. You're player number 14, they're player number 9. Okay, go ahead and take a second and do the your turn. You can pause the video. Okay, so weight of a baby. Weight of a baby would be numerical. The higher the number, the more the baby weighs. Color of Major League Baseball uniforms. So blue, gray, red. That would be a categorical variable. And zip codes for Michigan residents. This can be tricky because your zip code is a number. However, it is a categorical variable because that number does not have quantitative meaning. It just represents a geographical region on the map. Okay? So, now we're going to get into data displays for categorical variables, and we're going to graph 3 today. The first one we're going to do is called a pie chart. Some of you might be familiar with this, but if you're not, no worries. A pie chart. couple important things about a pie chart. Each slice is proportional to the frequency of the outcome, and I'll explain that. Each slice is proportional to the frequency of the outcome. Okay, so for example, the bigger the slice is in the pie chart, the more frequently it occurred, the more often it occurred. Okay, and about a pie chart, it's important to remember that each circle represents 100%. Okay, so in our example here, we have, it says during your last unit in your physics class, you took a quiz and a test. On the quiz, you earned 42 out of 51 points, so that was on the quiz, and on the test, you earned 78 out of 105. Organize the following data in a pie chart and briefly describe what you see. Okay, so I have two circles. One of my circles is going to represent how I did on the quiz, and the other circle is going to represent how I did on the test. Okay, so for the quiz, I'm just going to do some scratch work off to the side. Okay, for the quiz, it says I earned 42 out of 51 points. So 42 divided by 51, that's about 0.824 if we round accordingly, so about 82.4%. And on the test, I'm going to divide these numbers, 78 divided by 105. And on the test, my percent was, if I round accordingly, was 0.743. So 74.3%. Okay. And if you wanted to round those to the nearest whole number using 82 and 74%, that's fine. Just be consistent in your rounding. Okay, so if this one represents the quiz I had an 82.4%. So if now in order to divide this, it's going to be correct answers versus incorrect answers. So if I make this right here, that divides it into 1/4 and 3/4. But so this is 75%. Well, I scored a little bit better than 75%. So I'm going to make it about right there. So I sometimes estimate my pieces with either starting at 50% versus 50 or dividing it into quarters. Okay, so then let's see here. This part is going to represent the part I got right, which was about 82.4%, which would make this piece 17.6%. Okay. And we should have a key off to the side. So our key is going to be represented with correct versus incorrect answers. Okay, you can just leave one shaded and one unshaded. So I'm going to make correct unshaded and incorrect shaded. So that means since this is the correct, I'm going to leave that unshaded, and I will just briefly shade this one in. Okay, you could use different colors, different color highlighters if you want, whatever works. And then the next one is going to represent for my test scores. So on my test, I had a 74.3%. So again, I'm going to divide it into 1/4 and 3/4. Now, 74.3, that's like really close to 75. So maybe just a little bit. It's close enough. So this would be 74.3% were my points earned or my correct answers for the test. leaving this piece to be 25.7. It's up to you if you want to put those percentages in there, but I'm just kind of showing you. And then again, do our proper shading. Correct would be unshaded, incorrect is shaded. And that compares the two performances, your performance on the quiz versus your performance on the test. So now I need one last thing. I need a title. Every graph needs a title. So it doesn't give you much information here besides these scores are from your physics class. So you could just write physics scores, or if you wanted, it was the last unit, physics scores from the last unit. If they gave the unit a title, if they ever give a date, it'd be important to include that. You don't need to necessarily have last unit in there. If they gave the name of the unit, that would have been nice, but whatever you can. But certainly if there was a year or any important information should go in there. So that is using pie charts to represent our data for your quiz and test scores performances in the last unit. Now, the last thing it says right here is briefly describe what you see. Okay, and that's brief. One solid sentence will do it. So what do I see? What do these two pie charts tell me here? Well, it tells me that my performance was better on the quiz compared to the test. Make sure you don't reference the number of points. You don't want to say, I earned more points on the quiz than the test, because actually you earned fewer points on the quiz, but the quiz was out of less points. Since the totals are different, it's really important that you reference your performance or the percentage of points here. Okay, the percentage, I earned a higher percentage of points on the quiz than the test. That would have worked too. Just don't use number, because your totals are out of different numbers between 51 and 105. Okay, so let's look at another way to graph categorical data, and that is with what we call a segmented bar chart. This might be the one you guys are least familiar with today, a segmented bar chart. So a segmented bar chart is divided into rectangular regions. Oops, sorry, I was off the screen there. Divided into rectangular regions. And something else about a segmented bar chart that is, it's like think of a segmented bar chart as like a rectangular pie chart. Each slice, just like a pie chart, each slice is proportional to the frequency of the outcome. For a segmented bar chart, your y-axis is always going to be labeled as percent or percentage. Sorry, I'm writing in pen. And finally, your bar should have the same width. And each bar, just like a pie chart, each bar here totals, each rectangle totals 100%. So I'm going to graph the same data here as the first example and just show you how it would look in a segmented bar chart compared to a pie chart. So just like in the first one, it had two circles. I am going to draw two rectangles, one rectangle to represent my performance on the quiz and the other rectangle to represent my performance on the test. So as I just said right here, the y-axis is labeled as percent. I am going to label my y-axis, which is my vertical axis, as percent. And since it has to go up to 100%, I got to make sure I reach that. So I am just going to go by tens. Now I'm going to go by tens, but label every other increment. Because sometimes when you label every increment, the numbers kind of get crammed in there and difficult to read. So I'm just labeling every other one. If you want to label everyone and go 10, 20, 30, 40, that's fine too. Okay. Now I'm going to have one rectangle that goes up to 100%. That's going to represent my performance on the quiz. And another rectangle that goes up to 100%, that's going to represent my performance on the test. Now keep in mind, I made my rectangles 4 units wide here. Whatever you choose is fine, but just make sure, like we said earlier, bars have the same width. So make sure whatever you choose, it's consistent for each bar, the one that represents the quiz and the one that represents the test. Okay? We'll do the quiz first. It was the same numbers, 42 out of 51. And if you remember from the first problem, 42, your performance on the quiz was 82.4%. So I am going to draw my line a little bit above the 80. And then for the test, your performance was 74.3. So here's 60. 70, so almost about halfway between 70 and 80. Now I have to make a key to make sure I know what represents what. So I am going to have my correct answers be unshaded again and my incorrect be shaded. So I had about 82% right on the quiz, so that's unshaded, and incorrect's going to be shaded. It's up to you if you want to put the percentages in there. If you don't need to. We have our vertical axis labeled here to help us with that. Now, last thing is every graph needs a title, so we'll just call it last physics unit, whatever. You could use the exact same title as you did for the pie chart. It's displaying the same information. Okay, so what did we use here? We said physics scores from the last unit. Okay, now I want you to notice real quick is that I was consistent with how I made each bar. And what do I mean by that? When I graphed the correct answers were the lower portion here for my quiz performance along with my test performance, which makes it really easy for a reader who's reading this graph to make an observation that you did much better. Well, you did better on your quiz than you did on your test, because they can tell that right away by looking at this bar is higher than this bar. If you would have flip-flopped one and would have had one of the shaded underneath and the other shaded up top, it would be difficult to make that comparison. Okay, so it's really important that you're consistent here, that both my correct answers were underneath for each bar, therefore both my incorrect were on top for each bar. So again, it says briefly describe what you see. Another way, let's see here. Here I compared performances. Another way is to talk about your percentage. So you could say, I scored a higher percentage, or I correct answers on my quiz compared to the test. I had a higher percentage of correct answers on the quiz than the test. Again, notice I talked about a percentage, okay, because there weren't the same number of points, total points offered on the quiz and the test. Okay, the last categorical, the last way to craft categorical data that we're going to talk about today is what's called a bar chart. Again, for a bar chart, your bar should have the same width. In addition, you guys, the height of each bar, this time, so you're talking about the height of each bar is proportional to the frequency of the outcome. Okay, and then the last one that makes this a little bit different is that, just to be careful for a bar chart, your data is grouped differently. And what do I mean by that? So in this, you're going to see in this example, it's going to be grouped as correct versus incorrect answers. Not quiz versus test like we did for the two previous options. So let me show you what I mean. Our y-axis, just like the segmented bar chart, our y-axis is still going to be labeled as percent. And I'm going to go up to 100%. Whoops, sorry, that should be 60. I'm labeling every other one. Okay, remember, you're more than welcome to label every increment, but sometimes it gets a little difficult to read when you cram the numbers in there, so I recommend just labeling every other one. Okay, so like I said, your data is going to be grouped differently here. So along my horizontal axis, I'm going to have my correct answers grouped together and my incorrect answers grouped together. And that's going to make it easy for me to make these comparisons on which performance was better, the quiz or the test. So, and then off to the side on my key, I'm going to have my quiz, which I'll call shaded, my quiz performance, and my test performance, which I'll call unshaded. So, correct answers on the quiz, if you recall from the previous one, correct answers on the quiz was 82.4%. Now, pick a width for your bars. You can pick it to be 4, you can pick 3 units, 1 unit. I'm going to go with 2 units. So it was 82.4. Just be consistent. Bars have the same width, so just be consistent whatever you choose. And quiz was shaded. Now, for test correct answers, my test correct answers was 74.3, and that's going to be unshaded. Okay, and now be consistent. So since I use 2 units here for my bar width, I also have to use 2 units for my bar width in the incorrect category. So quiz incorrect answers. Well, if correct answers were, let's see here, 82.4, that would mean incorrect would be 17.6. Okay, and then for test, if, let's see here, 74.3 was correct answers, incorrect answers, remember, were 25.7. Okay, leaving that unshaded for test. Again, you can use the same title because you're displaying the same data. Okay. Now the reason why our correct and our incorrect answers are grouped together is because if these two bars were separate and not next to each other, it would be difficult to make the observation. If they were separate, it would be a little bit trickier to make the observation of which performance was better, the quiz or the test. But because they're right next to each other, you can quickly see that this bar is higher than this bar, meaning the shaded bar performance was better, and that was your performance on the quiz. Last thing, briefly describe what you see. You're displaying the same data, so you could write exactly what you had down here as well because it's displaying the same information. You had a better performance on the quiz versus the test in this unit. I know I worded this one a little bit different. Remember, you're just make sure you reference how your performance or the percentage, not the number. So here I said I had a better performance on the quiz than the test in the last unit in physics. Okay? So one last thing before you get to your worksheet we have is just a brief reminder of some requirements that we're going to have for all graphs in this class. So this is something we're going to reference all semester long. So keep in mind, graphs should always have a title. Axes should be labeled, so that's both your vertical and your horizontal axes with numerical and verbal descriptions. Representation should be keyed, so usually I put that off to the right, but make sure your key is clear. If you're using colors or if there's just two, you can just use shaded and unshaded, whatever it is, make sure that's clearly labeled. Representation should have their values labeled when necessary. And also your graph should be neatly presented. So if you need to use a ruler, rulers will be available, but just make sure you take your time and graphs are neatly presented. So one last final comment. I said this a few times, but just a reminder, when comparing distributions, it's important to use the percentage of observations rather than the number of observations, to help prevent a graph from being misleading. For example, in sports, teams will always play more games in the regular season than the playoffs. So it's important to talk about your percentage because if you're talking about your number of hits, for example, in baseball, in the regular season versus the playoffs, well, you have a lot more opportunities during the regular season because you play more games. So of course you're going to have more hits. But if you really truly want to make a good comparison of the two performances, it's all about your percentage. Just like in the quiz versus the test, your quiz is probably always going to be less points than the test. So it's all about your percentage of points you earn, not the number. Okay? Good luck on your worksheet, guys.